All right, hello. I'm going to show you how to install Robot Virtual Worlds, get some of the settings set up for students to just start playing around. I'm always a huge fan of whenever you're doing anything with programming or software, the kids do it either through a guided video like this, or maybe you could even stand up at the front and show it, depending on your students, through a projector or something. But there are always going to be issues with installation or use of the software, and they're very specialized for each student. So I just think it's more efficient to have everyone trying to do it on their own, and then you can work with students individually. Otherwise, it takes a little bit to get them all caught up and make sure everyone is seeing the same thing. It might take a little longer, but ultimately I do think it's actually less work. So first, if you go to Robot Virtual Worlds in a Google search, it will come up with the links right here, and it is the first link, robotvirtualworlds.com, and you can see this VEX and NXT simulator. So click on that, and you should come up to this page right here. So this simulator can be used for VEX robotics, but also LEGO Mindstorms, which is the NXT control system. So you can, depending on the funding available at your school, if you've used this before, maybe you already have it, but I'm going to show the free trial. And this is a good way for you to kind of explore the software with your students and see if it's something that you actually want to pursue or not. You get 10 days free. So just FYI about that. So you click on your free trial. And this gives you some of the information about the computer system specifications that are necessary to run this. If you have a Mac, it will ask you to use a Windows virtual computer, either through a USB or a different hard drive or something. So ultimately, you're still running this through Windows regardless, but it can be done with a Mac. I have done it on a Windows PC, and that's what I recommend. So if you have a Mac, the installation will be a little bit different, but I'm not going to show that here. Okay, so you can check the specifications here, hit next. It will ask you if you already have Robot C installed, or if not, most likely no. Robot C is how you download, or sorry, how you program these robots and how you actually compile to the robot itself. So hit no. It will ask you which version. I am using the VEX robotics system, so I will click on this right one, and you can see it will start to download right there. Once you do that, it will either take you to this page, or it will take you actually back to this page, sorry, step 2, where you can then say, yes, I have Robot C installed. And so whichever one, it really doesn't matter. So once you have that installed and once you have it downloaded, which I actually already do, it will come up with these icons. So you can see graphical Robot C or Robot C for VEX. The graphical is ultimately just the block coding version instead of the text-based coding, so you can actually choose whichever environment you want. And then it will also bring up the virtual worlds. So this is the actual programming environment, and then the virtual world software is separate, but it is linked to Robot C. So you'll see about that. Okay, so once you get that, I already have it open here. You open Robot C, and again, if you choose the graphical, it will look a little different. I'm showing the text-based. Okay, so you open up this start page, and what you should see is you have VexIQ in the platform type. So if you go to the robot menu, platform type, it will be selected to VexIQ. If you are using a Vex Clawbot, like I am, you will switch to 2.0, but I'm going to hold off on that for now. You also want the compiler target. For us, we're doing simulation in virtual worlds, so you want to select virtual worlds right here. Okay, so click on that. It will change some of the options a little bit. You don't actually download to the robot, so that's what's different up here. For the window, you want to select which virtual world to use. Palm Island is the one that I want my students to use as the training afterwards, or after they're done setting this all up. If you don't see this, select download more packages, and then you've got all these options here. You can see Palm Island is right there. So if you need to install it or update it, or you want to use a different system, then this is how you do it. Okay, so I'm going to make sure that Palm Island is selected. Excellent. The compiler target is virtual worlds. For right now, I'm using VexIQ, even though I'm actually going to use the the 2.0 Cortex, but Palm Island is not on that system, so that's why I'm using VexIQ, but they're very similar. All right, so that is kind of your setup of the Robot C software. So now what you want to do is open a sample program, which might actually take you to this page first, and you want to select basic movements. Moving forward, you can actually do any of these, but moving forward is very standard. It's just literally roll the robot forward. Once you have this, you can explain the code a little bit if you would like, or you can leave it up to the students to read. Every line is commented. So set the left motor to half power, set the right motor to half power, and then wait 2 seconds. So that ultimately means it will be running forward at half power for 2 seconds. Okay, so then you can say download to the robot, which will take it to the virtual robot. So this window should pop up, and you hit play. It will take you through a little explanation video, which I'm going to skip, but it basically explains the challenge of what you're trying to do. And the whole point is to get to the other end of the island while doing some tasks along the way. And ultimately, it just means moving and turning. So it's a good training. And then once you get to these pages, it'll explain what to do. So you want to move your robot forward from the starting point. The way to do that is to open a sample program, which we have already done. And then you want to compile and download the program, which we actually already did too to get to this page. And then you hit the play button and it will send the code to the robot. Okay, so I don't think this button works, no. So the way that you do that is hit the start button in Robot C, which will move the robot forward a little bit. Saw you moved. And that's a little annoying, so you can set up your windows differently if you would like. And then it explains you're trying to get around to the map. Okay, and then we shows the starting point here. So you can get rid of this window, and ultimately you're just trying to move around the map. So I can show, look, we moved roughly halfway to this next little arrow, so I can hit the play button again, running the same program, and I moved to that checkpoint. Okay, so now what I would probably want to do is turn left. So I can go to File, open another sample program, and then you've got a few different turns. So you've got point turns or swing turns. If you want to explain what these are, that is totally fine. But if not, again, they should be able to look through and read this. So for this code, set the left motor to full power reverse, set the right motor to full power forward, wait for 1 second. This one, set the left motor to full power forward, set the right motor to full power reverse, wait for 1 second. So those do 2 different kinds of turns, and you can see which one happens first by downloading this to the robot, and then hit play. Oh, that was really fast. So what we could probably do is, instead of full power, cut that down just to slow it down enough for them to see. So it's moving pretty slowly. And you can have them change this to whatever values they want. You can also increase the amount of time, just so, again, they can visualize what this all does. So now doing one turn at first over 4 seconds and another turn over 4 seconds. So download to the robot and hit play. And you can see at first it's turning left, and then it switches to turning right. So they can play around with these numbers until they figure out, well, how do I get it to align right down this little ramp, and then they'll have to go the other way. And they can explore all the different sample programs to get this done. All right, and then while they're doing this, again, a lot of them will come into issues with the program or the coding, but they'll all be very different for each individual student. So this is your opportunity to walk around and help them as needed. Excellent, thank you.